And we are live. Hello. Back coding again. Today we're continuing the Langflow deployment, and we're still dealing with security issues. So we really want to focus on network policies and then see if we can integrate a single sign-on keycloak into Langflow. We'll fork the project and update the React application and the backend application. So that's still to do. So network policies, and then we'll skip the OAuth proxy. We'll just fork. Just add this fork Langflow and update and add keycloak. Okay. So that's the goal for today, at least for the next hour or so. Network policies. All right, let's start with that. Okay, maybe we should do a little review about network policies first. Let me get the chat up. Chat is up. Okay, cool. All right, network policy. Let's just start a new tab in here. Why not? Let's reuse this slide deck here. Network policy. Policies. Okay. So network policies. Now, in this specific case, we're talking about Kubernetes network policies. So the idea here is to manage the network within the Kubernetes between the pods. So when you deploy your pods, they talk to each other. The traffic flows on the network there. By default, is everybody has access to it. So we do want to practice zero trust and start adding network policies to our deployments so that we can control the traffic flow. First thing, when it comes to network policies, you need to have a plugin install in your cluster. Okay, so there's multiple plugins. The two ones that always kind of come up are Calico. That's the one we are using. What's the other one? Cilium is another one. WeaveNet, WeaveNet for some of the maybe older clusters. Where else? Anyways, so you have to have that installed in your Kubernetes cluster, right? So this is your networking plugin that allows your cluster to read the network policies, apply network policies, execute network policies. It just basically makes the whole thing work, right? Without it, you can define network policy with your cluster, but nothing's going to happen. So you need that plugin there to actually implement your network policy. Where else? What are some of the basics here I need to cover? I'll just start coding, and then we can come back and add more stuff in here. All right. So getting back to our code base. So just as a review, we did implement Langflow Helm chart, our version. We can say it's production ready version. With all the bells and whistles. We have deployed it with Terraform, and in fact, it's running right now. There we go. We added security to it as well, or authentication and authorization that's provided through Langflow. So right now I logged in as super user. And you also have this access at admin page, so you can go and add your users here. So, and that's why one of the reasons why we need a single sign-on, so we don't have to manage users in multiple applications, right? We can just do it, especially for enterprises. You always have external system that manages your employees, your users, and you just want to use that system to integrate it with any of the applications. So we want to not use the authentication authorization that comes with Langflow. But right now we can say it's deployed, it's production ready. However, some of the non-functional requirements, let's call them that, are not correct. So before we jump into dealing with the authentication authorization and single sign-on, let's deal with network policies first. Now, I always like to leave network policies to the end of the deployment because, when it comes to network policies, sometimes you might get false positives. So you might not know if it's your deployment that's bad or is the network, right? Is the traffic not flowing because you have a container issue or some configuration issue, or is it's the network, right? So now that we have, fully deployed Langflow application with front and back in the database, in fact, let's have a look at it. Let's refresh this. So we have those three different things here, back and front end, and the database and its namespace. It's running. We can use the application. Now it's time to apply the network policies to both of the Helm charts. So there's a network policy for Postgres, and there's network policy that we added to our Langflow Helm chart as well. So when I start with network policies, I always like to start with kind of basic use case. In fact, I was just about to draw some diagrams here. I'll just create a diagram. Test cases. That's going to be a graph viz. I like using graph viz diagrams and saving them in Git and just getting that whole idea of diagram as code. So then you can have your source code with your diagrams, and you have a source code for your diagram as well, and you can just generate images from it. So I always like to use this graph viz online here to build my graph viz. So let me just grab this quickly. I'll have to put it in here. And let's just have a look at the image here first. So here, I'm trying to set up test cases and test the kind of basic implementation, and then progressively test more complicated kind of network policy implementation. So in this case, if you look at the diagram here, for the first test case, no policies. All the communications allowed. So we have a test client and we have a front and back and then database, right? So, the test client should be able to talk to any of these pods. Okay. Now for the test client, I always like to use a specific container. Just FYI, where's my script? I'm just working on the script right now. I sort of started gold plating it right now, just for fun. Adding more things than I should be adding to it. But I'll reuse the script for automated testing later. So yeah, there's no waste here. So I'll write a script here just for just a kind of quick testing, and then I'll just package it as with automated testing framework. So we can reuse the script many times. Okay, so when it comes, so I like this this specific netshoot container. GitHub. There we go. So it's a nice container. It comes with all the tools you need, Linux tools. And it's very useful to troubleshoot networking issues and just anything related to networking. So if you look at, there you go. If you look at the tools here, what's included, you can see all the usual, network Linux packages are included. And the reason they're included here is because they're not included with your container. Right? Your container should not have any of these things, your application container, because it opens up vulnerabilities for hacks, right? So we never install these packages with our, application database, whatever the container is, except for utility containers, right? Because these tools obviously cause a security issue. Because just, to use those tools, you need to open ports, right? And a lot of times we close ports, specifically in containers and pods, so we can, deal with security issues. Anyway, so you have lots of tools here. It's a nice container. So that's the one I use. And I'll be using some of the networking tools here, like nmap and tcdump and nc and all this, and things like that, and ping and curl. Curl is probably the one we'll be using the most. Again, curl is one of those libraries which should not be included with your container. You should always remove it. That package, you should not allow people to, execute into your container and then start executing curl commands. You want to remove as much of that functionality as possible for any of your application containers. So curl is one of those things where it's a big no-no to have in your container, but it's essential for debugging. So we're gonna, it's included in this container and we're using it. Okay. So getting back to the graph viz diagram here. So these are kind of test cases here that are done with kind of not the deployment of Langflow, but just kind of standing containers. So I can kind of test out the script first. So if you look at the script, you can see I'm using, I'll just make this a little bit bigger. I'm using Nginx here as a stand-in for the front and back in the database, and then I'm using this client here. It's just so I can just set up things, in a controlled environment before I start hitting, the Langflow React application or the Postgres database, right? So I can kind of play around with these, containers here, set them up, and then test specific, network policies here, which is just implying here, like this one here, deny all. And I can just kind of get an idea, understanding what's happening, and have a nice clean environment where it's not dependent on the application logic. It's just, just basic Nginx container, right? So it gives you a nice kind of playground. Anyway, so let me run this while we go through some of the diagrams. Let me just put this on screen here. So we'll create a namespace for it, and then we just create the pods and start applying the network policies, and then just doing simple curl to see if you can actually make a connection, TCP connection between those pods, those containers. Like in this one here, we have deny all. So going back to the graph viz diagram, we have the basic one, allow everything. Then we just test another extreme, deny everything, right? And then we just, have different kind of test cases that we go through. Allow front end, block all the other ones. There's a tiered application here. So test client accesses front end accesses back end, and back end is allowed to access database, right? And this is the one we actually really care about, because when it comes to our Langflow configuration, the browser, for example, should only have access to the front end, but also any other container that we deploy within the same namespace should not be allowed to access specifically the database or the backend unless we allow it access, right? So if you do have another kind of web application, it should be allowed to access the backend, right, based on labels, but not the database. So clients should never have access to the database. We only protect, the only thing that can have access to the database is just the backend, right? So we just want to block any access to the database except for the backend. And then, based on label specific stuff here, so we just test labels here. And then at the end, we just test the egress, the outgoing connection, the outbound connections. There's no reason why your containers should be talking to the internet, right? Now we do have egress set up on the cluster, so you can actually, leave the network and talk to the stuff outside of your Kubernetes network. But that's for specific use cases. In general, there's no need for your Postgres database to have access to the, outbound traffic to the internet. It's not going to grab any plugins. It's not. There's just no need for it, right? So that kind of reduces the blast radius for hacks and vulnerabilities. So when somebody does get into a database, you're blocked off, right? The only thing you can do is just stay within the container, and you can't siphon off the data to the some external site, right? So you want to block that. So that's the idea there, right? Anyway, so these are the kind of the 6 test cases that I'm just going to set up there in the script. So it did execute all the cases here, so we can see, the baseline access to everything. We didn't apply, deny all traffic network policy as expected. Everything is blocked, and then we're kind of playing around with different labels here. So in this case, only allow front-end traffic. Yeah, sure, the thing is blocked. Same here, tiered application again. The client can only speak to or have a communication with the front end, can talk to the backend database. And then at the end, we also have egress here, right? So we tried to hit an external site. I even forgot what I used. I think I went to google.com. Where's my script here? There you go, example.com. So just try to, basically go outside the network and access it. Yeah, no, too. Okay, you've been blocked. Okay, so in the same script, what I started to do is just to add Langflow connectivity test as well, so we can run it before we apply the network policy and after, just to kind of get a validation here. And also, I'll probably repurpose the script with automated testing as well. And yeah, so that's the diagrams here. Beautiful. Okay. So let's, and at the end, we just want to clean up, yes, delete the namespace, and all the, containers, pods within the namespace as well. Just clean up. Okay. So while we wait, so I'm trying to now set up the repurpose the script for testing Langflow namespace and 3 deployments that we have there. So just writing the script here quickly. Labels, no, that's not the labels I want there. So we're going to grab the deployment, the backend, and the Postgres deployment. Okay, that is not correct. Oh, come on. All right, so that's our deployment, and let's just grab some of the labels here. What? Oh, 1 second. Okay. Just getting distracted by the comments here. All right, so labels. Maybe just do this visually instead of in a terminal. Anyway, so we have labels here, so we can just grab things by a label, a pod. Okay, let's do that. And the one we want right now is the front end. All right, so you can see the labels here. So we probably will use the something's going to be unique in this case is going to be the front end component here. Just use this label. Let's move this to the side. We can do show labels here as well, just to show labels. So we can have the labels here. Okay, so let's use. No, that's not the one I want to use here. That is incorrect. Oh. So I want to use. I'll use this one here. Okay. And same thing for, let's get the stateful sets. Yeah, ship two of them, the backend and the database. Yeah, let's put this in quotes, so it's not going to complain because of the slash there. Now in this case, we want to get the backend component here. And let's get the Postgres as well. For the Postgres, let's use, I like to be consistent, but I see I wasn't consistent in my naming. Oh, Bitnami Helm chart wasn't. So let me use this one here. All right, so again, what's the goal here? The goal here is to have a connectivity test. So you can test multiple use cases before applying the network policy and after. Okay, right. This is what I get for copy and pasting. There you go. Okay, let me see. So I did add a usage thingy, show usage at the top. Let me see if that actually works. Right, so there we go. So we're going to use it. Should probably make this configurable. So I'll come back and change this. I'll make this pretty. When I start, when I put this in for automation testing, I'll make this obviously a variable, configurable variable. For now, just going to hard code the namespace here. Let's just run this quickly and see if you have any bugs. All right, so it got oh. All right. All right, stop. Okay, so let's just fix it up here quickly. So what happened here is, there we go, let's do this. All right. Well, so this works. Check name exists. Check if the different components are there. The pod names were okay. Front end, back end, that was good. You can see there's your deployment. First from stateful set or zero order, zero from Postgres stateful set. And then we got into a little bit of trouble. Waiting for the pod to start. And we're here, getting details. Yeah. All right. Let's adjust these labels here. Actually, did I put in multiple places? Oh, no, it's just there. Okay. Yeah, this one happens when you copy paste from a different script. Right. So service. Let me get the services. I don't remember what the services labels were. They should be the same again because we made it consistent in our Helm chart with the template, and we applied the template label template to all the different manifest files. But I can just double check here. Covert Langflow. Let's get all the services. Does it have show labels? Show labels. Oh yeah, okay, that's okay. Right. Okay. That's a good point. Let me double check if the Helm chart had good labels. Where's the service here? Yeah. Okay. So yeah. So the labels are common. So we reuse the same label everywhere, and we have this component here, so you can use the same thing. So we added this component to pretty much all the different assets here. Just distinguish the components, and you can use it as a selector. So yeah. Okay. Back and. Actually, wait. In this case, I don't want the headless service. I would like to have the non-headless service. And I did not add. I should probably add it, different name in here, just distinguish it, just for selection purposes. Because right now, when I do the selector for the service, we'll pick up both of them. I like to distinguish both of them. I'm not going to change the Helm chart right now. Let's move this to the side. Right, and we can see that here. So there's the primary one. I can use the same one. And for the component, we have front end, back end, and back end. And that's where the problem is going to be, right? Nice. So we'll fix this in a second. So anyway, so here, get a big component. For the backend, let's get a backend component. And we'll just have to adjust this one here. And for Postgres, what do we use for Postgres? We use the instance. Okay, let's use the same one just to be consistent. Should probably make these variables, and I probably will later just to make it customizable, easier to customize. Okay, so the only problem we have right now is with this service here, backend service. So if I do this by run this right now, get service, and I'll do it based on the label. I should get two, right? Yeah, I don't want to get two. I just want to get the non-headless one. Should I change the Helm chart? Component is not the right selector here because it is part of the backend component. Always these little micro decisions, right? No, I'm not going to change it. I like to get both services when I need to by component. So in this case, I'll just exclude the headless one. So let's do that. All right. So let's see what's different here between those two. Right, exactly the same. So we have an option to change the labels in the Helm chart or add a filter here. Filter. All right. Let's see if we can do a quick filter here. Let me have a look at the doc. because I don't remember the filters. Who does? Right. So let's do this based on the cluster IP. Right. So let's just add that. We can definitely put a more specific label here, but we really can't, since you can see they're the same, exactly the same. And that's how we have in the Helm chart. So we are going to add a filter. Where's the filter? Filter. We go, where's the filter? Okay, so you go dash O. All right, so where's my filter? Where I should put the filter? Oh, you know, let's just test the filter here first before we apply it. So let's add, let me see. We'll do this based on a JSON path. And the only thing that we have is the known for the headless. We know it's headless. So let's exclude the headless one. So we'll do, yeah, let's do JSON path. JSON path. And let's just add our JSON object in here and the quotes. So the cluster IP is, well, first of all, it's an item, so I have to get the items. And once we have the items, so this is, yeah, just regular JSON path you would say with JQL, or JQ, sorry, JQL, JQ utility. Same idea here. Items, let's get the first item. And then, no, hold on, I don't want to get the first item. I want to get, I should probably put this in JQ Playground just to play around with this quickly. Let's do brackets. Oh, it's painful. Let's do get the spec, get the cluster. It's capital IP, right? Cluster IP, and does not equal to none. Is it capital none or lowercase none? None. Okay. Yeah, obviously going to have a problem. And we need to, hold on. Hold on. So yeah, that makes sense. So we'll just continue this. At the end here, we're going to go dot, as we have the top spec, dot cluster IP. Let me see where I messed up. There we go. That works. Sweet. So we get just one. And that's the cluster IP. Okay. All right, well, that was painful. Okay, so we did the same component. We just changed the JSON path, which is, let's grab the whole thing. So I'll mistype it. So we'll put the JSON path here. Just get rid of this one. Okay, and same here. All right, well, that was a little bit painful. Okay, so that's going to exclude the headless service, and we'll complete the test. Okay, let's see if where else I messed up. Let me just look at the test. Okay, so I get this list of the policies, should be none initially. I don't want to put true here. Let me change this. So I changed the script at the top, remove the classical set E at the top, if you scroll to the top, and just replace it with, just arrow trap. So it will continue when it fails. So when you get a 0 from your command, it can just continue. Because, it might fail, for example, when you say curl, external website, and that curl command fails and the script fails, but then and we wanted to continue, right? So instead of using set E, which would just exit based on any error, just replace it with with a trap in a bash script specifically. Okay, so going back here, where the hell did I put that now? Script is getting unmanageable. We're gonna have to break it up into small chunks soon. All right. What is a boo-boo here? Wait, hold on. That's not what I want here. For the backend, so that's the servers. So I want the cluster IP, but here I want the port. Right. So I want the port from the ports. Right. All right. Cool. So we have the ports. Now we can start running the tests. Yeah. Okay. I'm gonna change this in a second. This if statement. I don't like this if statement here. I'm gonna put an or condition here, and yeah, just see if this works, and then I'll make it pretty in a second. Okay, so that looks good. Let's see if it runs. Yes, let's clean up the test client, but we can see there's some issues here. So I already like the script because it's giving me some good feedback, but let's fix these errors here. So we are running Linkerd, the service mesh. We have to account for that, and we do have a few issues here. The connection should be allowed, but it's not allowed right now, even though there's no network policy. You can see no network policy found right now. So we should be able to, with the curl command, access these different containers here, or pods. So let's have a look at that. Yeah, I should have the chat overlay so we can see the chats. Yeah, I'd enable it. Maybe next time. Yeah, okay. All right, let's finish this script here that we can then reuse multiple times with every deployment, just to make sure we have our network policies well defined. So what it fails. So here, right, so this is failing. Now this should be allowed because there's no network policy. And I know this test connectivity function is working because I just tested with my test namespace. So what is happening here? And I did name it test client, didn't I? Double check. Test client. I did. Okay. All right. What's happening here? Where is this curl here? Feels like I have a boo-boo somewhere. Getting service details. Here. What did I mess up? Oh, here. All right. All right, so now we'll fix that bug. What else do we have here? All right, so test client to front end. Let's have a look at that first. All right, let me rerun it. So test clients, if I bring back my dashboard, Kubernetes dashboard here, and if we look at the namespace, you should see there's the test client, right? So the idea here is that we get something into the namespace on the same network, and it executes the test, right? So we don't have to. So it happens within the cluster. All right, we get a little more information. Okay, so let's maybe fix the Linkerd issue first, the service mesh, because that's important. And then we can focus on the first test. All right, so I'm going to ignore this failure for now. Major failure. Tremendous failure. And we need to fix... Right. All right, so this is the issue here. So again, curl should not be part of your pod. Now here we're trying to make an attempt to install it. And when it's installing it, it doesn't know which container to install it to, right? Because it's, it's trying to get into Linkerd container. We need to tell it to get into a specific container. So what do I do with this function here? Oh, I'll move to true. Where's my function? Here. I just realized I probably don't have to skip this test till I update the Langflow containers. Let's see if you can fix this curl install, and then we'll leave these tests till a little bit later. I'll come back and because I still want to use them for automated testing. I don't want to think about network policies. I just want to, deploy them and test them, see they're good. Every time you deploy, just make sure they're good to go. So I'll finish the script later, but for now, I'll just fix this part. So we need to give it a container. So, oh boy. This was my naive implementation when I was doing the Nginx deployment here. Where is it? Right here. So this pod has one container, right? When we deploy Langflow, we have multiple containers. Are we having connection issues? I see people pinging me connection issues. Where are? No, we're still good. Maybe there was some connection issues on the YouTube, but we're good so far. Unless it's my internet again. Another snowplow destroying my internet. Okay. Never mind. Okay, moving on. So, what's the idea here? Right. Let me see. What else do I need to do here? Well, let's make this conditional as well, right? So, yeah, let's just add some defensive coding here. Show me. Yeah, we should, because the container flag, right? So, all right. So just put an if statement here, because if this is empty, you're still gonna have to see it's gonna fail. Okay. So yeah, that makes sense. All right. So let's do local container flag. Come on, cursor right for me. Flag. If I can spell flag. Okay. And then let's make this an if statement. So if, there we go, container name. Oh, beautiful. Thank you, cursor. So that's that. And then we can put this into here. Replace that at C. Boom. Oh, damn it. Wrong copy paste. Here, like so. Like so. All right. So it's going to work for both use cases. If there's just one container or multiple containers. Okay. Okay. Right. All right. Containing. Okay, I'm good. All right. So now let me update. Let me see. I would like to know also what container I'm updating as well. So installing. Let's pod name, and let me put yeah, let's do that. Let's put a little conditional here, statement here. So let's do container name. Yeah. Thank you, Chris. That's what I was trying to remember. Okay. All right, let's do this. So now if you go to here, let's specify also the name of the container. So where's the name of the containers? We called it front end and back end, as I recall. Yeah, so we have two containers here. There's a Linkerd proxy, service mesh, and front end. So we'll just try to hit the front end container. And for the back end, I just think we just call the back end in the Helm chart for consistency, which would make sense. Double check. Yeah, two containers, back end. All right, cool. front end, and this was going to be back end. All right. All right, so this is still going to fail. It's just, I'll say, well, let's not delete this. All right. And that's why we'll probably, what? What did I do with the namespace? What just happened? Did I just delete my namespace? I'm just did a typo there. No, namespace does exist. Okay, let me see. I just did a typo there. Where's my namespace? Check. What? What's happening here? Oh, I'm not looked into. I got kicked out of my Google account. Okay. Again, security. Those session injection hacks are all over the place. Ask Linus Tech Tips and all the other YouTubers getting hacked. So let's not be one of those. So just log in. Yeah, so we have a organization policy in this cloud, Google Cloud, and all the other clouds where we force people to log in continuously. And I was the one that set the policy, so hooray for me. All right, let's export this variable here, our proxy. Let's have a see, check if it's if we can connect. There we go. Okay. Let's run the script again. All right, so I know this one is failing. I don't know why it's failing. It looks good. Yeah, I think it should be allowed. Okay. We'll have a peek at that in a second. Just want to make sure all the other tests are passing before we apply the network policy. Oh boy. Right. Okay. So when I fork Langflow and add the SSO, I also added the containers to be a little bit more manageable for production environments, to be able for us to customize them. So in this specific case, we can't install. So just have a look at the container. Where's my Langflow code base? Let's have a look at Picadero containers. Let's close this off. Where is the container? Front end. Let's look at the template here. What is this? Nope, we don't care about that. Here, let's have a look at these containers here. See if they're ready for the prod. Yeah, this one should allow us to update its packages. I'll fix this up. Obviously, there's maybe not obvious, but there's some obvious issues here with this container. We'll make a mental note to fix this. What about the backend? There you go, backend Docker. Oh boy, there's not much here. Okay. Right. So one of the biggest issues that you can see here, and this is kind of for most Docker developers, that maybe don't realize that for production systems, we need immutable things, objects, right? So if I look at this thing here, that's a label. That's a Docker label. Now, that is mutable, right? So which means that I can build this many times on this underneath the same label. And if I deploy this into production system and I keep reusing the container and refreshing and grabbing from the repository on the same label, I don't know that it's changing because again, it's mutable, right? So you can have bugs in here. People can just rebuild it many times and change it, right? So while this is not good. I mean, but most people just take this as the way to deploy things to production. So, and just to reemphasize, we need predictability in our production systems, in our build pipelines, and predictability comes with immutable objects, right? This is mutable. So anyway, so I'll fix this once I fork this. We'll use the digest, so we'll know specifically. We'll have a very we know exactly what image is used, what digest. So that's a digest is the hash. So you can either have a hash or you can have a label, right? Or tag here versus a digest. So we always want to use a digest, or if you're using a label, then a good way to use a label is with your Git hash, right? So if you're building your CI/CD pipeline and you're building containers, you can use the Git commit hash that just committed and whatever the application changes on, and use that as your your label, your tag. So then that at least is somewhat immutable. So that kind of protects. Plus, it gives you you can quickly look at the image name with the tag of the Git hash and see where it came from. You can easily trace it to specific code base, right? So it has that traceability as well. Anyways, so let's get back to my script here, and which I think I'm gonna abandon until I deal with some of these container issues, and then I'll make it so it's set up for to be testable as well. Let me first peek at the error message quickly and see if I can just fix it here, or we need to move on to the next task. Hold on a second. Did I make more boo-boos here? Let me see. Where is my install? That should work. Default container. Right. No, not link proxy. I want the front end container. Why isn't it grabbing the front end? Did I misspell something? Let me run this with X option here, so we can have a little bit of a debug. All right, here is the debug. Let's have a look. Oh, I see. Okay. We need to adjust the script a bit. Oh boy. And yeah, let's adjust the script. Okay. Okay. Start from here. All right, so first thing we want to fix is the container issue also is applicable to here. Where is it? Right here, into the curl as well, okay? All right, so let's fix the test connectivity first. And then we can fix this one here again. Okay, so for test connectivity, we have the front and back end. And look at the thing I used there. Do I need to update this one here as well? Right. Right. Multiple containers again. Oh boy. I should probably redesign the script to be less naive. But I'll just patch it right now and then we'll move on. All right, let's patch this. All right, so this execute command here from pod, as you can see, this one is, let's use this one as an example. Here, test client to front end, or where's the arrow here? This one arrow here. So in this case, we're going from, what's the output here? Here. Let's see how we can fix this quickly. Namespace from test client to front end service. That should be good. Where's my local? To name. Wait, where's it front end? What? Did I mess up the to name? Yeah, it's fine. Right. Okay, so there's a problem here, obviously on this line here with multiple containers again. Where is the output here? And we're going to, I'm just going to double check if that's the right IP, just for testing purposes. Yeah, when you're debugging, you want to kind of eliminate the obvious things first. So in this case, oh boy, move this to the side. Let's just double check that that's the right IP address and the right port number. So in this case, we're trying to connect to the front service. So on the services, let's have a look at services quickly here. And here are the services. So this one is 14.077. So this one. Okay, great. So that's the right one. That's the right service. Okay, and which is connected to your front end pod. So that's good. And where else? And port 80, that's the right port. Okay, so we have the right connection. And where's the default container? Wait a minute, did I messed up somewhere here with my kubectl comments? Oh, right, okay. Mystery solved, okay. Oh boy, okay, so service mesh, right? Let's look at this client here. It has a linkerd proxy as well, right? So that's on purpose. We set the service mesh labels on the namespace, so anything that goes into the namespace will get linkerd container, side container injected. All right. So so the test client doesn't know which container to use, right? Okay. Let's fix that. So there you go. That's actually a valid error, which I didn't think about. So that's why that naive script initially with test namespace maybe was not the best, because that test namespace did not have a label to add a service mesh into it. And well, now it's quite useless to me. In retrospect. Okay, so in here, I'm going to update this as well. So we want to add C container here. Now, what's the name of the test container? So it will be test client. So the container is test client. So it should be like this, test client. Now this has to be configurable as well. So let's let's always have this, because that's how I call the test client. What's my test client? So I'm okay with always hard coding this value here, because when I install the test client, I give it a name, test client, which is, there we go here. All right. So it's just going to be the same name. Yeah. Okay. So I'm comfortable with hard coding it in that specific case, because it's always going to be test client. And let's not clean up the test client. Let's run this again. Better results. Okay. Service mesh, it's definitely required, but sometimes you just don't think about it. Okay. All right, sweet. Okay, we have enough of the working script to actually apply the network policy and see if it works. Let's remove the X here for debugging. Let's run it without it. There we go. Now we're getting successes. Oh, except for the database, right? So database, it requires a different client. Let's skip that part for now. So it's not HTTP connection making, so curl doesn't make sense, obviously, for a Postgres database. But at least we have some validation that the client can talk to different pods, and there's no network policy preventing it from doing so. What else do we have here? Issue here. And I don't like this part here, so we'll fix it. Let me look at the time. Oh, we have 10 minutes maximum. Okay. And let's fix some of these so then we can just come back next time and just apply and put policies. Now think about this. Okay, so let's fix the main one. Where's the main issue? Here. So this is still to do with installing the curl. So it's trying to install it in front end container, and it's complaining about the default container. Oh, did I make a boo-boo there? Let me see. And this is running apt-get. Right, doesn't have it in that path. Yeah, I don't think this is going to work. Let's do this manually first. And so what we want to do is we want to kubectl execute a command in namespace kubert Langflow. We want to get the pod. Let me just grab the pod. Where's the pod? Where's the pod? Here. In this pod. And we want to do it in C front end. Oh wait, then I can see. Okay, thank you, spell check. I can see it. There's the boo-boo. Okay. All right, let's run this again. Okay. Yeah, we have to fix the database client. We'll just change from curl to maybe telnet, just to kind of get some feedback. All right, looking better. All right, now let me see. So let me still do it manually, just to confirm that the command is working. So we want to do kubectl. We want to execute a command within the container with this pod. Oh, come on. I did not need that cursor. I did not need that. XV. All right, in front end. I'm just do the same command here. So we have, let's do this. Oh, are you messing with me? And put the namespace here as well. Right. Yeah, we didn't make a read-only file system, and that's the issue here. So let's have a look at the pod security. Let's have a peek at the front end. So we started with a very strict pod and container security. Let's see if we need to relax it a bit. So let's have a look at, where's the pod security? Where are you? Okay, well, I see the container security. Where's the pod security? So we do have this one here. That's what they read only. Where's the pod security? Am I blind? Oh, there it was. Okay. Well, all right, let's make this a little bigger. So, first of all, at the pod level, not the container level, this is the security that we applied. Again, it's very strict. So you can't run this route. You have to have specific group ID. And this one is not read-only. So this one allows for the access of files. Now let's look at this security here, security context. here. This one here, that's on the container. Right, so read-only files, okay. So we do want this for prod again. We set the context security to read-only on purpose. And then we have to, again, allow specific volumes to be mapped as, as write. Like for example, here, you can see we have temp and we have Nginx cache. So Nginx cache was added because of the read-only. Again, it's the whole idea of inconvenience that comes with security. So do I want to add the ability for people to install additional packages? No, I don't, because that's a security issue, right? I'd rather handle this within containers. So what I like to do as a design pattern, use multi-stage build in a container. So if I go back to Langflow, and that's what I was talking about, updating the containers. So let me explain what I mean and why things like that are useful for testing. So Langflow, here you go. So if you look at this Langflow container or image, Docker file, it's a multi-stage build, right? So we have a builder, which, that's the buildy thingy. And then we have the runtime, right? That's on purpose. So we don't have to package everything in the runtime container. So it's much smaller when you actually run the container. However, for security reasons, for this runtime, we should basically remove everything that is not essential to this application, right? Things like installing Linux packages is not essential, right? That should be done in your Docker file. So what I like to do usually is basically release two different containers, two different images in the same Docker file. So I have another multi-stage build in here. So if I would follow the same pattern here with this mutable Docker tag here, so I would use the same thing here. The only difference I would do here is call this runtime testing, okay? And I would execute this only, I would, build the container with the CI/CD pipeline with multiple tags, one with different targets, one with runtime, one with runtime testing. And in this case here, I can just install the packages I want. So for example, in this case, I'm going to add, let's just grab this part. All right, go away. So Git, I would install curl here, okay? Just add the curl, and so then I don't have to install it as part of the the script. I can just replace the image during testing, and everything stays the same. The only thing is that we have additional package in this image, right? So this kind of allows us to test. Now, does this kind of contradict this whole idea of parity, having the same images in production, same for testing? A little bit, but in this specific use case, we're testing just networking, right, specifically, right? And we just adding one specific package, right? So the idea here that this package causes some malfunction to your application is very low. So again, pros and cons here. Anyway, so we would do something like that, and then the script is much simpler. I don't have to change it, update the containers at runtime to be able to, add curl command to be able for me to test connection between containers. Anyway, so that's something we'll do later. I'm just looking at the time, which means I have to finish soon. So going back to our slides. Where's my slides here? All right. Right, network policies. Still not done. Okay. Probably going to have to finish later tonight after meetings. So network policies, deploying them is fairly easy. You just enable flag true false. Testing it is where we want to spend some time on. That's what we're trying to do right now. Write a script that we can test the network policies, and also reuse the same script for automated testing, quotes acceptance testing from a DevOps point of view. And let's end it here. Yeah, I'll apply the network policies later today. And the next session, we're just going to dive into recoding Langflow. We'll grab the code and just start adding our React and Python code to both front end and back end quickly, so we can add single sign-on for SSO. Okay. Anyways, that's it for now. Thank you, guys. Hopefully this was useful. I'll post a script and the graphs, graph-based stuff somewhere. We just have to find a place for it. And then, anyways, we're good to go. Bye. Where's my end stream button? Bye.